All right, everyone. So today we're going to cover the last page of your Chapter 2 notes packet. So this should be page 24. And we're just going to take a look at a different type of graph for a rational function. And remember when we said if a polynomial was top-heavy, there was no horizontal asymptote. That's still true. There is not one. But if the degree of the numerator is exactly one more than the degree of the denominator, there is a new type of asymptote called a slant asymptote. So it's slanted. It's going to look something like this, or maybe it's going in the other direction. So here are a few things that we need to know. A graph can have a horizontal asymptote or a slant, but not both. To find a slant asymptote, you're going to divide the numerator by the denominator. Ignore the remainder if there is one. Finally, the slant asymptote will be in the form of y equals mx plus b. Let's graph two more rational functions that both have a slant asymptote. So one thing we could say just right at the start here, looking at our denominator, we've got a vertical asymptote at 1. Now, normally we would find the horizontal asymptote yet, which this case we do not have 1. So notice how the degree of the numerator is 2. That's exactly 1 more than the degree of the denominator, which is 1. And so we're going to divide the numerator by the denominator. And we can use synthetic division for this. So let's turn that -1 over here into a +1. We'll list out the coefficients representing the x squared minus x plus 1. There's a lot of 1's here. We'll go ahead and bring down the first number to the bottom. 1 times 1 is 1. Add the column, giving us a 0. 0 times 1 is 0. Add the column, giving us a remainder of 1. Remember before we said we can ignore the remainder. Now, our answer represents a polynomial 1 degree less than what we started with. So this is y equals 1x plus 0, which is really just the same thing as y equals x. So that is our slant asymptote equation. Now, the process for getting the y-intercept is the same as what we did before. Sorry about that. That's the lunch bell, start of lunch. Okay, so if we plug in 0 for x, all of these are going to go away. That's going to leave us with 1 over -1, which is -1. Now for the x-intercept, we get the x-intercept by setting the numerator equal to 0 and solving for x. Let's see, if we were able to factor this one, we would have to find two numbers that multiply to 1 and add to -1. But it doesn't look like we have two numbers that will work. And so if we were to put this into the quadratic formula to try to solve, we see that a is 1, b is -1, c is 1. I want to show you what happens here. So we put it into minus b plus or minus b squared minus 4 times a times c all over 2 times a. This is going to end up being 1 plus or minus the square root of 1 minus 4, which is -3. And so because the solutions are imaginary, that means that we don't have an x-intercept. Okay, the other thing to know is that it's very uncommon for graphs that have slant asymptotes to have any symmetry. So we can skip the symmetry test for these. Okay, so let's start to put the pieces together of our graph. So we have a vertical asymptote through x equals 1. Our slant asymptote, the line y equals x, has a y-intercept of 0. It's got a slope of 1, so it's going to kind of perfectly divide our graph in half diagonally. And let's go ahead and put in the y-intercept of -1. Okay, so we're just going to really think about two sections on this graph. So remember before we were color coding the different sections and we wanted to figure out what the curve was going to look like. So we just have the section to the left of the vertical asymptote and the section to the right. And knowing that our curve has to get closer to the asymptotes, again, there's two possibilities for how it could look. And I want to just show some options off to the side here. So slant asymptotes work together with vertical asymptotes. So one possibility is that the curve can be on the outside. So see how it's getting closer to each of the asymptotes? It's going to look something like this. Another possibility, there's our vertical, here's a slant, is that our curve could be on the inside, looking something like that. The curve will either be both on the outside, like the blue graph, or both on the inside, like the red graph. We're never going to have like one of each. So if we take a look at what we have over here, we know that it has to go through this y-intercept point. And so we know that the curve is going to be on the inside. And so it must be on the inside for the other part as well. So if we actually just highlight the answer part, curve is going to look something like this. And also it would make sense that it's not going to be on the outside because that would make x-intercepts, but this graph doesn't have any x-intercepts. And this is what that would look like, plugging it into Desmos, looking very similar to the graph that we did by hand. Okay, let's look at this final example. So we can start going through our steps again, stating this one has a vertical asymptote of 3, no horizontal because it's top heavy, but it is slant because the degree of the numerator is exactly one more than the degree of the denominator. So we're going to divide the top by the bottom. So from the x minus 3, we'll turn that into a positive 3. We'll list this off to the side. We've got 1, negative 4, negative 5. We'll go through our synthetic division. Ignore the remainder. So we're just interested in this part. This represents y equals 1x minus 1. So this slant asymptote line has a slope of 1 and a y-intercept of negative 1. I'm hesitant to write this because that's not the y-intercept of the rational function. That's just the y-intercept of the slant asymptote. Okay, let's think about our y-intercept this time. If you plug in 0 for x, all of these parts go away. We're left with negative 5 over negative 3, which simplifies down to be positive 5/3. And our x-intercept is found by setting the numerator equal to 0 and solving for x. Now this looks like it is one that we could factor. So what multiplies to negative 5 adds to negative 4. Let's do negative 5 and positive 1. All right, so we've got two values for x-intercepts. So it looks like we have an x-intercept at positive 5 and at negative 1. All right, so time to make our graph. So putting the pieces together, we've got a vertical asymptote at x equals 3. The slant asymptote is going to pass through negative 1, and it has a slope of positive 1. So it's going to look something like this. We have y-intercept at 5/3. Just estimate the location there. X-intercept at positive 5 and negative 1. So we have some clues here that this is going to be the curve on the outside because it has to go through our intercepts. So it's going to pass through the intercept, but then it's going to be getting closer to the asymptote as it's continuing on. So this other side would look something kind of like that. I didn't draw that perfectly, but we can imagine that's just one nice smooth curve. So checking this one on Desmos, that's what that would end up looking like.